Good morning to respected ma'am. I am Jitarak studying in SRNT Engineering College and I am from Computer Science and Engineering Department. I am studying in CSCG section. On the purpose of CA2 assignment, I am giving about video presentation about the graph traversal techniques and DFS on the advanced data lecture and algorithm analysis. And my topic is about graph traversal techniques DFS. In this slide, we know about the introduction to graph traversal and DFS. In graph traversal involves visiting all nodes in a graph symmetrically. Depth first stretch. It means DFS is a fundamental traversal technique that explores as far as possible along each branch before backtracking. DFS is widely used in various applications such as pathfinding, cycle detection, and topological sorting. Yeah, in graph, all nodes in the graph is symmetrically twisted to each other. Depth first search. It means DFS means depth first search. Search is a fundamental traversal technique. We already know that these applications such as pathfind DFS is very used in various applications such as pathfinding, cycle detection, and topological sorting. Let's know about the depth first search. That means DFS. DFS is a traversal algorithm that starts at a selected node and explores as deep as possible along each branch. It uses a stacked data structure, either implicitly or via recursion, to keep track of nodes to visit. The algorithm marks visited nodes to avoid revisiting and ensure all accessible nodes are explored. As well as we know, DFS is a traversal algorithm at as deep as possible along each branch. It uses a stacked data structure to keep track of nodes to visit. The algorithm marks visited nodes to avoid revisiting and ensure all accessible nodes are explored. How DFS works, step by step process, you know that. Begin at the starting node, mark it as visited, and explore its adjacent nodes recursively. For each adjacent node, if it is unvisited, recursively apply DFS on it. Backtrack when all adjacent nodes are visited, returning to previous nodes to explore other branches. Beginning at the starting node, mark it as a visited and explore its adjacent nodes recursively, returning to previous nodes to explore other branches. Implementation details of DFS. DFS can be implemented recursively or iteratively using an implicit stack. In recursive implementation, the function call itself for each unvisited neighbor. In iterative implementation, a stack data structure manages nodes to visit next. In iterative implementation, a stack data structure manages nodes to visit next. DFS can be implemented recursively or iteratively using an implicit stack. Let us know about the applications of DFS. DFS is used for detecting cycles in directed and undirected graphs. It helps in topological sorting of directed acyclic graphs. DFS is also utilized in solving puzzles, maze traversal, and component identification in connected graphs. The DFS helps in topological sorting of directed acyclic graphs, that also known as DAGs, and DFS is used for detecting cycles in a directed and unidirected graphs. Let us know about the advantages and limitations of DFS. DFS is simple to implement and uses less memory compared to other traversal techniques like BFS. It can be inefficient for large graphs if not implemented with proper stopping conditions. DFS may get stuck exploring deep paths unnecessarily, especially in infinite or very deep graphs. There are so many advantages and limitations for DFS. DFS is simple to implement and it can be inefficient for large graphs if it is not implemented with proper stopping conditions. DFS may also get stuck exploring deep paths or very deep graphs. Let us compare the DFS and BFS. Unlike BFS, that also known as breadth first search, which explores neighbors level by level, DFS dives deep into one branch before exploring others. DFS is better suited for problems requiring deep exploration, while BFS is ideal for shortest path problems. Choice between DFS and BFS depend on the specific problem requirements and graph structures. The DFS is better suited for problems requiring deep exploration, while BFS is ideal for short path problems. Here are some of the references on my topic, graph traversal techniques, DFS. So this is my video presentation about my topic. Thank you for your patience, ma'am. Thank you for listening. Thank you so much.